This lesson is about the domain and range of compositions of functions, and let's start off with the basic function notation. If you were asked to find f of 2, this would ask you to take the 2 and substitute it in for x in the f equation. So f of 2, the 2 would replace the x, so it would be 2 squared minus 4, which is 0. If I were to ask you to find f of negative 5, this is a little bit trickier because you have to remember that anytime you substitute in negative numbers, you have to use parentheses. So I'm going to substitute the negative 5 in for the x, and then square it and subtract 4, and that's 21. So for the most part, if you have something in here, f of 3, that would be 3 squared minus 4, which is 5. It gets trickier when you have things like f of delta, that's delta squared minus 4. If you had f of smiley face, that would be smiley face squared minus 4. You have to remember that function notation is asking you to substitute whatever is in the parentheses for x. And so this leads us to the composition of functions, which is like f of g of x. Except for, that was how it was written in your Algebra 2 book. In your pre-calc book, it's f of g of x. It sort of looks like fog, except for it's a small, weird O. It's not quite really an O. But these are asking you the same thing. And since the g function is inside the parentheses, this is asking you to take the g function and substitute it where the x is. So the f function, the outside function, is x squared minus 4. I am going to erase the x and replace the x with the square root of x minus 2. So, in a really simple world, the square and the square root would cancel, and I get x minus 6. And this is the case that f of g of x is equal to x minus 6. But if this were a line, its domain would be all real numbers. But with functions, you can't just give them their own domain. You have to look at where they came from. And this function came from the f function and the g function. The f function has a domain all real numbers, but the g of x function has restrictions that x can only be greater than or equal to 2. And so the domain of the composite function, so the domain of f of g of x, is also from 2 to infinity. At this point in the class, you can choose how you'd like to write domain and range, unless they ask you to give the problem in unit notation. So from here on out, you'll just have examples. Like if I said to find g of 3, that would be the square root of 3 minus 2, which is 1. But if I were to ask you to find g of f of 4, the first thing I would do is rewrite it so it looks like this, g of f of 4, and then you work yourself from the inside to the outside. So I'm going to start off with just this part, f of 4. And f of 4 is 4 squared minus 4, which is 12. So I did the inside. Now I'm going to do g of 12. G of 12 is the square root of 12 minus 2, which is a square root of 10. So for composition of functions, you work yourself from the inside to the outside. Let's say I had g of h. Let's say we had g of h of 5. I would rewrite that as g of h of 5. And from inside to outside, the first thing I'm going to do is figure out h of 5. H of 5 is 2 times 5 plus 1. That's 11. So since this piece right here is 11, I'm really finding g of 11, which is the square root of 11 minus 2, which is 3. If I were to ask you to find g of h of x, this would be asking you to substitute the h function into the g function. So the h function is 2x plus 1, so I have the square root of, instead of x minus 2, I'm going to erase the x and replace it with the h function, 2x plus 1, and simplify it. It's the square root of 2x minus 1. This is the final answer. Its domain has both the restrictions of h and g. H is unrestricted because it's a line, but g's domain has to start at 2 and go from 2 to infinity. So the domain of the composite function has restrictions from both the parent functions. In this section, you'll also be asked to multiply, divide, to add, and subtract. And for these problems, you just have to work them out and state the domain. F of x times h of x would be x squared minus 4, the f function, times 2x plus 1, the h function. A problem like this would require you to know how to FOIL. 2x cubed plus x squared minus 8x minus 4. In the next example, division, you would have to take x squared minus 4 divided by 2x plus 1. This doesn't have anything that cancels, so you would stop right there. If you had to graph it, it would be kind of complicated because it has a slant asymptote. If you're asked to add, you just need to worry about combining like terms. And that's about it. You will also be asked to decompose functions, and that can be a little bit trickier because usually decomposed functions have to do with squaring and factoring, and this problem doesn't really look factorable. So I might have to do something tricky like take x squared plus 6x, leave a blank as if I were completing the square. But then when I complete the square, I have to add 9, but there's no other side to the equation, so I add 9 and subtract 9 at the same time, so that adding and subtracting 9 balance each other out. And I get x plus 3 squared minus 13. And so if I were to write this in the decomposed form, I would say that h of x is equal to x squared minus 13, and another function, g of x, is equal to x plus 3, and so the f of x function can be decomposed into h of g of x. That was kind of a tough decomposition. Here's an easier one. Let's say you had y equals x plus 1 squared minus 5 times x plus 1. In this case, you notice they both have an x plus 1 in common. So I could decompose it by saying the first function is x squared minus 5. The second function is x plus 1, because that's what gets substituted into the other. And so the composite function y is made up of f of g of x. And keep reminding yourself, f of g is not the same as f times g. You have to pay attention to what the little dot looks like. There's also really nice notes on the Math is Fun website, And I included a link to it on the page that has a link to this video if you would like to check that out.